This is 1-4, solving inequalities in one variable, 1-5, compound inequalities, and 1-6, absolute value equations for regular and honors, and 1-6, absolute value inequalities for honors only. Match each inequality to the meaning of a symbol within it. H is greater than 50, would belong with the middle. H is less than or equal to 20, would be up here. 30 is greater than or equal to H, is my last one. Is 25 a solution to any one of these inequalities? Well, plug in 25 for H. Is 25 greater than 50? No. Is 25 less than or equal to 20? No. Is 30 greater than? Yes, 25. So it belongs to C. Is 40 a solution to any one of these? Is 40 greater than 50? No. Is 40 less than 20 or equal to 20? No. Is 30 greater than or equal to 40? No, so none. And is 30 a solution? 30 is not greater than 50. 30 is not less than or equal to 20. 30 is not greater than, but 30 is equal to 30. So it belongs with letter C. Solving inequalities is the exact same steps as solving equations. We do our distributive property. Watch your signs. -4 times 3x, -12x, -4 times a -1, +4, plus 6x, greater than or equal to 16. Always check to see, do we have like terms? We do. Combine them together. A -12 and a +6 makes a -6x plus 4 greater than or equal to 16. What you have to be careful about with inequalities, you have to do everything on the left, bring down your inequality, everything on the right, bring down. Isolating for the x, subtract 4 to both sides, -6x is greater than or equal to 12. Divide by -6. The rule of inequality states that when you are multiplying or dividing by a negative number, the inequality symbol has to switch. And then 12 divided by -6 is a -2. And now we have to graph. -2 is in the middle. On a number line, numbers to the right are greater, numbers to the left are smaller. Because it has an equal sign, that means that -2 can be a solution to this inequality. So it has a closed circle. And then numbers less than -2. -3 is smaller than -2, so it's all the numbers to the left of -2 that you would shade. So greater than, less than would have open circles. Greater than or equal to, less than or equal to would have closed circles. You can pause and try it and check these on your own. -3 times 2x, -6x, -3 times a +2 is a -6, less than 10. Add 6 to both sides. -6x is less than 16. We are dividing by a negative number, which means that less than has to switch to greater than. Positive divided by negative, negative. And then 16 and 6 can both be simplified by 2. 2 goes into 16 8 times, and 2 goes into 6 3 times. To help you graph, you could divide 8 divided by 3, and it gives you -2.6 repeating. Which would be your -8/3. So that makes it between -2 and a -3. It's an open circle because negative 8/3 is not included in your answer, and all numbers greater towards the positive number associated towards your right side. 2 times 4, positive 8. 2 times negative 2x, negative 4x, greater than 1. Please be careful. A lot of you have a tendency to want to add 8 because you see that minus sign. But if you add 8, 8 plus 8 does not cancel. So that should kind of give you a red flag that you did something wrong. That's a positive 8. To make it cancel, subtract 8. 8 minus 8 is 0. Minus 8 to the other side. Do not forget to bring down the negative with the 4x. 1 minus 8 is a negative 7. Dividing by a negative 4, which means that because we divided by a negative number, greater than is now going to change to less than. I can't simplify the number 7 4, but a negative divided by a negative is positive. And then to help you graph it, you can do 7 divided by 4, should give you 1.75, which is closer to 2 than to 1. It's 1.75 is not included, so it's an open circle. 1 is smaller than 7/4 or 1.75, so you would shade towards your left. Just like equations that we got infinitely many solutions and no solution, process is still the same, but now you have to read the statement and see if it's true or not. You can't just look at the numbers. Negative 3 times 2x, negative 6x, negative times negative, positive 15, greater than negative 6x plus 9. Variables are now on opposite sides. When I cancel out my negative 6x, I do have negative 6x to both sides. Add them, they both completely cancel out, and then you have to read what your statement says. Does a positive 15, is a number 15 greater than a 9? That is true, so this would be an example of infinitely many solutions, and you cannot graph these. Same thing over here, 4x minus 5 less than 2 times 2, 4x, 2 times a negative 3, negative 6, subtract 4x to both sides. They completely cancel. Bring down negative 5. Is a negative 5 less than a negative 6? The bigger the negative, the less value it has, so this is not true. So this would be no solution. You can pause it, try these on your own, see if you get the same answers. Negative times positive, negative 8x, negative times another negative, positive 4, less than negative 8x plus 4. Cancel out my variables, positive 8x to both sides. They completely disappear. Now don't just look at the numbers because it's not an equation. You have to ask yourself, is this true? Is 4 less than 4? It is not, so this would be an example of no solution. Letter B, distribute the right side. Negative times positive, negative 6x, negative times positive, negative 3. Add 6x to both sides. They are both negative, so they're both going to cancel out. Is a negative 5 less than a negative 3? Yes. So this would be your infinitely many solutions, or IMS. Here, Derek wants to order some roses online. For what number of roses is it less expensive to order from florist A? So when is florist A going to be less expensive than florist B? So they're asking us to use X for roses. So the cost of X roses at florist A, $4.75 per rose, plus a one-time $40 delivery. When is that going to be less than florist B, which charges $5.15 per rose, plus a one-time delivery fee of $25? Then we have to go ahead and solve it. So we had 4.75x plus 40. When is that less than 515x plus 25? Variables on opposite sides. I always like going for the smaller one. 40 is less than 515 minus 475. You get 40 cents left. Minus 25. 15 is less than 0.4x. Divide by 0.4. This is extremely, extremely important. Leave the variable on the right side. So 15 divided by 0.4 is 37.5 less than. You got to keep the inequality where it's at. You got to keep the variable where it's at. So 37.5 is less than x. Now when you're solving a word problem and your variable is on the right, to answer the question, flip it completely around, and florist A will be less expensive when x is greater than 37.5 roses. You can't buy half a rose, so the next whole number greater than 37 would be 38 roses or more. Florist A would be less expensive. And then florist B would be less expensive when it would be 37 or less roses. This is just interpreting it for you. The solution is all real numbers greater than 37.5. However, the number of roses must be a whole number. So if Derek plans to buy 38 or more roses, then florist A is less expensive. If he plans to buy 37 or less, then florist B will be less expensive. Here's another example. The Art and History Museum offers a family discount card for a donation of $49. The table shows a price per person with and without the discount card. Without the discount card, each child is $10, each adult is $15. Once you pay a donation of $49, then each child is $8 and each adult is $12. Well, they want to know for how many visits will the total cost of visits, including the price of the discount card, be less expensive for a family of 2 adults and 1 child if they have purchased the discount card. So let x be the number of visits. So 8 and 12. So $49 discount plus 1 child, 8 for that many visits, plus 2 adults at $12 per visit, plus, when is that amount going to be less than not having the discount card, which was $10 per child, plus 2 adults at $15 each. So combining all my like terms, 8x plus 24x less than 10x plus 30x. My like terms, 32x, 40x, subtract 32x, 8x, and then 49 divided by 8, 6.125 is less than x. Again, it's a word problem. You want the variable to be first, so flip it all completely around. It will be cheaper when the number of visits is greater than 6.125. Again, you can't visit 0.125 times, so the next whole number greater than 6.125 would be 7. So for 7 or more visits, the total cost of the visits, including the price of the discount card, will be less expensive for a family of 2 adults and 1 child if they purchase the discount card. Reviewing 1-4. To solve inequalities, use the properties of inequalities to isolate the variable. So here they did the distributed property, -5 times 2x, -10x, negative times negative, positive. They subtracted 15 to both sides. They got 19. They divided by a negative. Because they divided by a negative, they flipped the inequality symbol. So x would be greater than or equal to a -1.9. Little do you know how to recap. 1/2 multiplied by x to get rid of this x. To get rid of the 1/2. Multiplied by the reciprocal. 2/1 to both sides. I could just multiply by 2. X is less than 12. If I were to graph it, it's not negative. It would be an open circle. X is not including 12. Then I have 11 and I have 13. 11 is less than 12, so I would shade towards the left. 6, multiplication, divide by a -4. But because I'm dividing by a negative number, x is now going to be less than or equal to a -5. Because it has an equal sign, -5 is included in my answer, so it is a solid circle. I have -4 on my right, -6 on the left. Numbers less than -5 are -6 and above, so to the left. Number 7, distribute. 8 is less than or equal to -4x. Negative times negative, +4. Subtract 4 to both sides. 4 is less than or equal to a -4x. Divide by a -4. 4 divided by -4 is -1 greater than or equal to x. When I go to graph it, it is a closed circle. 0 here, -2 here. -1 is greater than. -1 is greater than -2. So this one's also shaded to the left. Number 8, subtract 3x. I would have gotten rid of the smaller one. So I would have added 3x. It does not matter, but positive numbers are your friends. 6x minus 2 is greater than 4. Add 2 to both sides. 6x is greater than 6. Divide by 6, and x is greater than 1. That should have a open circle. Numbers greater than 1 are 2, 3, and above, so to the right. Lourdes plans to jog at least. At least means 1.5 is her bare minimum. So she can jog 1.75 or greater than 1.75. Write and solve an inequality to find x, the number of hours she will have to jog. Well, distance equals rate multiplied by time. So her rate is 3.75. I do not know her time, so that's my variable. And I know it's at least greater than or equal to 1.75. So when I divide, x has to be greater than or equal to 1.75 divided by 3.75. Oops, 1.5. That's why I was getting it wrong. So 1.5 divided by 3.75 is 0.4. And if you want to find out the actual length of time, 0.4 of an hour, 0.4 times 60 minutes, she has to jog for 24 minutes or more to at least reach 1.5 miles. For more practice, you can work on these. This was a warm-up. A video streaming company offers 2 monthly plans. Plan A, $3 per video viewed, plus a flat rate of $8 per month. Plan B, $5 per video, and no additional rate. Write an inequality when Plan A is less than Plan B. And N for videos. Plan A, $3 per video, 3N, plus a flat rate of $8. When is that less than? Plan B, that's $5 per video and no flat rates. So it's just less than 5N. Now be careful here, minus 3N. Again, you cannot put your variable on the left and leaving the less than symbol there. You got to solve everything exactly how it's written. Divide by 2, keep going to the very end. Once you have that variable by itself, then if you want to flip it at the very end and tell me that you would need N, it has to be greater than 4 videos, then that would be your answer. Number of videos has to be greater than 4, so 5 or higher. Still example 2, still 1-5, 1-4. Variables with inequalities with variables on both sides, no distributed property, no like terms, variable on the left, variable on the right. This was a warm-up, minus 1.5, 3.5 minus 1.5 is just 2x, greater than or equal to a negative 7, positive 19, cancel it out by subtracting it, but we're not technically subtracting it. Same sign, add and keep the sign, a negative 26, divide by 2, and x is greater than or equal to a negative 13. Because it has an equal sign, it is included in my answer, so it's a closed circle. Numbers to the right are smaller, numbers to the left are less, and x represents all numbers greater than negative 13, so it's shaded to the right. Now this is 1-5. Compound inequalities. How can you use inequalities to describe the sets of numbers graphed before? This graph shows the solutions of 2 inequalities. The 2 inequalities form a compound inequality, which is made up of 2 or more inequalities. Write the inequalities to represent the solutions shown in each part of the graph. When they are shaded apart from each other, this represents an OR compound inequality. X, your variable represents the part that's being shaded. So x, the part that's being shaded, has to be something to -3. -3 has a closed circle, so that means it's included in my answer. And numbers to the left are -4, -5, -6. The bigger negatives have less value. So x represents all numbers less than or equal to -3, or x represents 2 cannot be included in my answer, so that's why it's an open circle. And to the right of 2 we have 3, 4, numbers greater than 2. This is the only way that you can write a or compound inequality with the word or in the middle. We have ands, which can be written two different ways. You can write it just how the ors are written, with the word and in the middle of the two inequalities. Again, x represents the part that's being shaded, so x has to be something to -4 and x has to be something to 1. -4 has a closed circle, so it's included in my answer. It's being shaded to the right, so those are numbers greater than -4, and the numbers are being shaded to the left of 1, so those are numbers less than 1. You can also write the ands with only one variable, with the x in the middle, and basically the smallest number, -4, would go on the left and 1 on the right. Smaller number on the left, bigger number on the right. Since this is not changing, x is still on the left and 1 is on the right, x is still smaller than 1, but since this got flipped around and x was greater than -4, -4 is going to be less than or equal to x. And if you want to check that you did it right, they have the number 0 here to use as an example. -4 is less than 0 and 0 is less than 1. So the compound inequality describes the graph is x is greater than or equal to -4 and x is less than 1. Or you can also write it as -4 is less than or equal to x, which is less than 1. And are the only ones that can be written like this. So you can pause and try this one on your own. Seeing that it's shaded in the middle, automatically I know it's an and. -2. So again, you can write it as x is something to -2 and x is something to 6. Because 6 has a closed circle, I know it has an equal sign. X does not, so it's an open circle. And then ask yourself, what is 0 to -2? 0 is greater. So again, x represents this whole shaded area. The numbers to the right of -2, x is greater than -2, and the numbers to the left of 6 are less than 6. Or you can write it with the x in the middle, -2 on the left, 6 on the right. Smallest is always on the left, biggest is always on the right. Just flip this one around, less than, and x is less than or equal to. Whenever you write it the special way for and, the variable is always in the middle, smaller number is always on the left, bigger number is always on the right, and the inequalities are always facing the left when you write it in this special format. Now solving them and graphing them. They are two completely separate problems. First one here on the left, add 7, 5x is greater than 20, divide by 5, x is greater than 4, or, now solve this one, subtract 3, negative 4x is greater than 8. Divide by negative 4. Because I divided by a negative number, x is less than a negative 2. So those are our two answers. And now we have to graph them both on the same number line. Please remember, number lines go from least to greatest. Negative 2 is smaller, it should go first. 4 is greater, it should go on the right side. Neither one of them have the equal sign on the bottom, so they are both open circles. Numbers greater than 4, 5, 6, 7, 8, numbers to the right. Numbers less than negative 2, negative 3, negative 4, numbers to the left. Knowing that it was an or, you should have known that they get shaded opposite from each other 99.9% of the time. Here's a try it. Again, two separate problems. Subtract 2, same sign, add and keep that sign. Divide by a negative 3. Because you divided by a negative, switch your inequality. Negative divided by negative, positive. 9 divided by 3, 3. Or, do our distributive property, 2x minus 4 greater than or equal to 6. Add 4 to both sides. 2x is greater than or equal to 10. Divide by 2, or x is greater than or equal to 5. Draw your number line. 3 should go first, and then the 5. 3 has no equal sign, open circle. 5 has an equal sign, closed circle. Numbers greater than 5, 6, 7, 8, shaded to the right. Numbers less than 3, 2, 1, 0, your negatives are to the left. And those are my ors. Here's an example of an and. Now the difference between and ors will always have the word or in between your two problems. Ands can either look like this, or they can look like the ors with the word and in the middle. Same concept. You're working inside the middle where the expression is, trying to get x by itself. Because you have two inequalities, whatever operation you're going to do to one side, you now have to bring to both sides of the inequality. So to solve for x, subtract 9 to the negative 12 and to that 16. Same sign, add and keep the sign, less than or equal to 7x. 16 minus 9, 7. Then multiplication, divide by 7. And a negative 3 is less than or equal to x, which is less than 1. If you did this correctly, the number on the left should be smaller than the one on the right. Negative 3 has an equal sign, it has a closed circle. 1 has an open circle. Negative 3 is smaller than 0, that would be to the right. 0 is less than 1, that would be shaded to the left. So ands should be shaded always 99.9% of the time in the middle. Here's a try it. You can pause, try on your own. Same concept. Two inequalities with an expression in the middle, trying to solve for x. Add 5 to both sides of that inequality. 2 plus 5, 7, less than 4x, less than 15 plus 5, 20. Divide by 4 to both sides. You can leave it as 7/4, less than x, less than 5. If you want to turn it into a decimal, it would be 1.75. Graph it. 1.75 and 5 both should have open circles. 1.75 is less than 2 and 2 is less than 5, so shaded in the middle. I just use a number that could be fit in the middle for x. substituted. Here we have Enrique plans a diet for his dog, River. River consumes between, that means and, 510 calories and 540 calories per day. He eats 1.5 servings of dog food each day. How many treats can she have? So model the situation with a compound inequality. Let X represent the number of treats that River can have each day. Write an expression to represent River's total daily calories. So 1.5 servings at 320 calories per serving is 1.5 times 320, which is 480, plus X number of treats at 15 calories per treat is 15x. So write a compound inequality. So 480 plus 15x is your expression that should go in the middle, and then 510 has to be less than or equal to that amount, and this amount has to be less than or equal to 540. So to solve it, subtract 480 to both sides, and we get 30 is less than or equal to 15x, which is less than or equal to 60. Divide by 15 to both sides, and 2 is less than or equal to x, which is less than or equal to 4. So River can have a minimum of 2 and a maximum of 4 treats. Suppose that River has new treats that are now 10 calories each. So it would be the exact same problem except with 10 calories per treat, still with between 510 and 540. Same concept, minus 480 to both sides. 30 is less than or equal to 10x, less than or equal to 60. Divide by 10. But now since the treats have less calories, River can have minimum of 3, maximum of 6 treats. Here's a practice of do you know how. I see that this is shaded in the middle. Write a compound inequality for each graph. This is an and. You can write it with the x in the middle. 2 is less than or equal to x, and x is less than 8. Or you can write it with the word and in the middle. X is greater than or equal to 2, and x is less than 8. You can distribute here 2 times 4x, 8x, 2 times 3, 6, greater than or equal to negative 10. Subtract 6 to both sides. 8x is greater than or equal to negative 16. Divide by 8, and x is greater than or equal to negative 2, or add 15 to both sides. Negative 5x is greater than 20. Divide by a negative 5. Because we're dividing by a negative, x is less than negative 4. So to graph it, negative 4 is smaller, negative 2 is bigger, negative 2 has a closed circle, negative 4 has an open circle. Numbers less than negative 4 are to the left, numbers greater than negative 2 are to the right. 9. Nadine plans to ride her bike between 12 and 15 miles. So between 12 and 15. Write and solve an inequality to find how many hours Nadine will be riding. Again, distance is rate times time. Her rate is 10 miles per hour. So 12 has to be less than or equal to that amount. That amount has to be less than or equal to 15. 10 we can use x. So divide by 10. So 1.2 is less than x, which is less than or equal to 1.5. So 1.2 hours, between 1.2 and 1.5 hours, will get Nadine between 12 and 15 miles. These are your ors, these are your ands. Write a compound inequalities. I see that they're shaded apart. When they're shaded apart, they can only be written with the word or in the middle. X is something to -4 or X is something to -1. It's being shaded to the left of -4, so that means those numbers are less than, close circle, equal to -4. X is being shaded to the right of -1, so greater than, close circle, equal to -1. Here you see how the ands can either be written with the word and or the expression in the middle. Here has the word and in the middle. Add 1 to both sides. 4x is greater than 4. Divide by 4. X is greater than 1. And distribute. Watch your signs. That's a +8. Negative times negative. Positive. Subtract 8. Same sign. Add and keep the sign. That's a -24. Divide by a -6. Because you divided by a negative, x is less than or equal to a +4. 1 should have an open circle. 4 should have a closed circle. Numbers greater than 1 are to the right. Numbers less than 4 are to the left. So it's between 1 and 4. The city council is planning a long, narrow park with a playground at one end and a fountain at the other. They want the playground more than 5 blocks from the fountain and both the items at least 2 blocks from the center of the park. The graph below represents the possible positions of the playground relative to the center of the park, which compound inequality represents the possible positions of the playground. I see that they're shaded apart from each other. So automatically C and D are eliminated. This represents an OR. If I go to my 2 problems, subtract 4, x is greater than 3. Subtract 4, x is less than or equal to a -2. Numbers greater than 3, open circle. Numbers less than -2, close circle. My answer should have been letter A. Absolute value. Definition of absolute value means how many spaces it takes that number to reach 0. So, same thing as solving an equation. You need to get the bars by itself. So I need to get rid of that addition by subtracting 2. 7 minus 2 is 5. So what numbers would it take 5 spaces to reach 0? 1, 2, 3, 4, 5. It would take +5. 5 spaces to reach 0, and it would take 1, 2, 3, 4, 5 spaces for -5 to reach 0. So any time you have a variable that's by itself inside the bars, absolute value, then you will always get the same number, positive, negative. So 5 and -5 would be the solution to this equation. If you want to check it, you can plug in 5 here. Absolute value of 5 is 5 plus 2 is 7. The absolute value of -5 is a +5 plus 2 is 7. So 5 and negative 5 should be your answers. Absolute value of 5 is 5. Absolute value of negative 5 is also a 5. They both take 5 spaces to reach 0. Never will can a number become negative taken outside of absolute value. Here, now I have an expression. This is a little bit different. So again, what would take 1 space to reach 0 on a number line? It would take 1 space to reach 0, and it would take negative 1 space to reach 0. So when you have an expression inside the absolute value bars, you have to make 2 equations, one with a positive, the other with a negative, because the absolute value of 1 is 1, absolute value of negative 1 is 1. So we need to see what can x be that would give me a 1, and what can x be that would make it a negative 1. So 2x minus 3, 2x minus 3. The expression always stays the same. Add 3 to both sides. 1 plus 3 is 4. Divide by 2, and x equals 2. That's one answer. These answers are always going to come out differently. A negative 1 plus 3 is 2. Divide by 2, and x equals 1. So your solution is a 2 and 1. You can check your work. Absolute value of 2 times 2 minus 3. Is that going to give me a positive 1? 2 times 2 is 4. 4 minus 3 is 1. Absolute value of 1 is 1. Yes. 2 times 1. 2 minus 1 is 2. 2 times 1 is 2. 2 minus 3 is negative 1. Absolute value is 1. 1 equals to 1. Yes. So my solutions would be 1 and 2. All right, before you can start making your 2 equations, you need to get the bars by itself isolated before you can make your 2 equations. So here I have to first get rid of that 8 by subtracting 8 to both sides. Please be careful. 5 minus 8 is a negative 3. This is not distributive property. Distributive properties involves parentheses. So to get rid of this 3 that's being multiplied to the bars, I am going to divide. So the absolute value of a number equals negative 1. There will never be anything that comes out of the bar and ends up to be a negative number, because there's no number that takes negative spaces to reach 0. So whenever the absolute value bars, once you isolate them, are by themselves and it equals to a negative number, your answer automatically is no solution. You would not separate into 2 equations. All right, so you can pause and try these on your own. See if you get the same answers. Letter A, 6 equals absolute value of x minus 2. Isolate the absolute value bars. Add 2 to both sides. 8 equals the absolute value of x. What takes 8 spaces to reach 0? X can equal an 8 and a negative 8. Letter B, this is not this is not distributive property. So to isolate the absolute value bars, divide by 2, keep the absolute value. once you get the bars isolated and it equals to a positive number, now you separate it into two equations. Because it takes two spaces to reach 0, and it takes negative two spaces also to reach 0. So subtract 5. 2 minus 5 is a -3. That's one answer. Subtract 5, and x equals a -7. If you want to check it, -3 plus 5, 2. Absolute value of 2 is 2. -7 plus 5, -2. Absolute value of -2 is a +2. See, there is nothing that I have to bring over to the other side to isolate the absolute values already by itself. So I can just go ahead in letter C and make my two equations. Add 6 to both sides. 3x equals 18. Divide by 3, and x equals 6. Add 6 to both sides. Adding 6 to a -12 is a -6. Divide by 3, and x equals a -2. So these would be your two solutions. Word problems with absolute value. The cruising speed of Kennedy's boat is 25 miles per hour. She plans to cruise at this speed for a distance either 10 miles before or after the 80-mile point as shown in the diagram. So she's going to go 80, 10 past 80, or 10 below 80. What equation models a number of hours, x, that Kennedy will travel? So absolute value, 25, the distance Kennedy actually travels, 25 miles per hour. We don't know how many hours. Minus 80. This would be the final distance from the 80-mile point, equals to 10 miles from the 80-mile point. So now she can either go 10 above or 10 below. So to solve it, there's nothing that I have to bring over to the other side. So now I make one with a positive, I forgot my x, and one with a negative. Add 80 to both sides, and the total farthest she would go would be 90 miles. If she goes 10 miles more and goes 90 miles at 25 miles per hour, it would take her 3.6 hours. If she goes 10 miles less, -10 plus 80, that would be 70. At 25 miles per hour, it would take her 2.8 hours. So this is just to kind of show you, if Kennedy travels 10 miles beyond the 80, then the absolute value is negative. If she travels 10 miles before the 80, the absolute value expression is negative. That's why we did one with a +10, the other one with a -10. So the solutions are your 2.8 and your 3.6. So now she drives a little bit less. She's now driving 20 miles per hour. Still 80, and then above or below the 10. So to separate it, +10, she can go 10 miles above, or she can go 10 miles less. Same concept. Add 80 to both sides. If she goes the 10 miles more, now going a little bit slower at 20 miles per hour, it'll take her 4.5 hours. And if she goes 10 miles less, 70 miles, it will take her 3.5 miles. This is for honors only, so if you are not in honors, you can just pause and end your video. For honors only, now we have understanding absolute value inequalities. Solve and graph two absolute value inequalities. The distance between x and 0 must be less than 3. So all values within 3 units to the right and 3 units to the left of 0 are solutions. So that's why x has to be less than 3 and x has to be greater than -3. So whenever it's less than or equal to in an absolute value inequality, that is representing an and compound inequality. So x is less than 3 and x, you now have to switch your sign to greater than and make that 3 negative. So now when we go to graph it, -3 should be on my left because it's smaller, 3 on my right. They are both open circles. Numbers greater than -3 are to the right, numbers less than 3 are in the middle. You can also write it as -3 less than x less than 3. When you see that it's greater than, those are going to be your ors. So here the distance between x and 0 must be greater than 3. Positive values of x must be more than 3 units to the right, and negative units of x must be more than 3 units to the left of 0. So that's why x has to be a number greater than 3, or x has to be a number less than -3. So again, when it's greater than or equal to, those represent your ors. So you have -3, smaller one on the left, bigger one on the right, numbers greater than 3 to the right, numbers less than -3 to the left, and they both have open circles. So letter A, solve and graph. Solving it, x has to be on numbers greater than 15, or x has to be a number less than -15. Letter B, x is less than or equal to 7, and x is greater than or equal to a -7. -15, +15, both of these have open circles. Greater than 15 to the right, less than 15, less than -15 to the left. -7 is smaller, 7 is positive here to the right. Both have closed circles, and less than 7 is to the left, greater than -7 is to the right, so shaded in the middle. So again, just to reiterate, greater than or equal to would represent your ors when it starts off, and then less than or equal to are your ands when they start. All right, members of the debate team are traveling to a tournament where they will stay in a hotel for 4 nights. The total cost for each member must be within $20 of $175. They can spend all $75, but they cannot go past it. So they can either go up to 195 or down to 155. Which of the hotels shown can they consider? Write an absolute value inequality to represent the situation. Let X be the cost per night of a hotel room. So 4 nights at the cost, so that would be 4X, then minus 175. Whether you're doing an absolute value equation or an absolute value inequality, it always has to have a minus sign inside the absolute value, because this is a number that you're going to be adding to the other side, and it has to be bigger than the number that it equals to or the other side of the inequality. And then the number that always goes above or below always should go after the equal sign or after the inequality symbol. So because you can spend all of 75, but you can't go above it, less than or equal to that 20. So absolute value of 4x minus 175, less than or equal to 20. So my first inequality that I'm going to have to solve, 4x minus 175, less than or equal to 20. And then 4x minus 175, flip your inequality symbol and make 20 negative. Add 175, add 175. 4x is less than or equal to 195. Divide by 4. And 195 divided by 4, 48.75. Add 175 to negative 20 is 155. And 155 divided by 4 is $38.75. So they can rent a hotel room that's between $38.75 and $48.75 a night. So Hotel A would be a yes, Hotel B would be a yes, Hotel C would be a no. So they can consider A and B only. This is just a recap. So the cost of the hotel room can be between okay, maybe not. The hotel can be between $38.75 and $48.75 inclusive, so they can consider A or B. So now the debate team increased their limit to 200 plus or minus 20. Would they be able to afford Hotel D at 55 per night? Let's see. So it's still 4 nights minus 200 less than or equal to 20. So 4x minus 200 less than or equal to 20, and 4x minus 200 greater than or equal to negative 20. Add 200 to both sides, 220. If we had made this a plus and you subtract it, you're going to get a negative number, and that would not work in pricing. So 220 divided by 4 would be 55, and add 20 200 minus 20 is 180 divided by 4 45. So yes, if they increase their price to 200, they would be able to afford Hotel D at 55 because it's less than or equal to 55. So absolute value equations. To solve an absolute value equation, isolate the absolute value expression, then write 2 equations and solve. So here, 2 times the absolute value, not parentheses, cannot distribute. They divided 2 to both sides, they got 9. Once the absolute value expression is by itself, separate it into two equations, one with a positive 9, the other with a negative 9. Add 17 to negative 9, one answer is 8. Add 17 to a 9, the other answer is 26. Honors only, absolute value inequalities. If the distance between x and 0 is less than or equal to, it is an and. If it's greater than or equal to, it is an or. So x is less than or equal to 1 means that x can either be less than or equal to 1 and x is greater than or equal to negative 1. If the absolute value of x is greater than 2, x can be greater than 2 or x can be less than negative 2. And then the one in the and, shaded in the middle, ors shaded apart. All right, we can try these. Solve each absolute value equation. Again, get the absolute value bar by itself. Minus 3, minus 3. 5 minus 3 is 2 equals the absolute value of x. So what numbers does it take 2 spaces to reach 0? X can equal 2 and a negative 2. Number 6, there's nothing to be brought over to the other side. The bars are already isolated, so make your two equations. 2x minus 8 equals 16. 2x minus 8 equals a negative 16. Add 8 to 16, and we get 24. Add 8 to a negative 16, we get a negative 8. Divide by 2, x equals 12, and x equals a negative 4. On a road trip, Andrew plans to use his cruise control for 125 miles plus or minus 20 miles. Write and solve an equation to find the minimum and maximum hours for his road trip. He's going 50 miles per hour. So 50 miles per hour minus 125 equals his 20 plus or minus. So separate it. 20x minus 125 equals 20. 5x, 50x minus 125 equals a negative 20. Add 125. 50x equals 145. Divide by 50. And he can go 145 divided by 50. 2.9 hours plus 125. 50x equals 105 divided by 50. So his minimum would be 2.1 hours. His maximum would be 2.9 hours. Solving graph. That one should be an or. That one should be an and. So number 8. 3x minus 6 greater than or equal to 9, or 3x minus 6 less than or equal to a negative 9. Add 6. 3x is greater than or equal to 15. Divide by 3. X is greater than or equal to 5. Or add 6 to a negative 9. Get negative 3. Divide by 3. X is less than or equal to a negative 1. Negative 1, positive 5. They both have an equal sign. So they're both solid circles. Numbers greater than 5 are to the right. Numbers less than negative 1 to the left, shaded apart. Number 9 should be an and. 4x minus 12 less than or equal to 20. And 4x minus 12 greater than or equal to negative 20. Add 12 to both sides. 4x is less than or equal to 32. Divide by 4. X is less than or equal to 8. And add 12. 4x is greater than or equal to negative 8. Divide by 4. X is greater than or equal to negative 2. Close circle on both. Negative 2, positive 8. Numbers greater than negative 2 are to the right. Numbers less than 8 are to the left, shaded in the middle. Here's some more practice if you want some. And we can do number 2 here on the bottom. Another recap. Oh, this is a good one. So to get this by itself, subtract 14 first. 3, absolute value of x minus 2. 14 minus 14 is 0. 0 is a number, don't freak out. Divide by 3. Anything divided by 3, any number divided into 0 will always be 0. I cannot put this into positive negative because 0 is not positive or negative. So this would just be one answer, and x would just equal to 2. And that was lessons 1.4, 1.5, and 1.6.